Assalamualaikum warahmatullahi wabarakatuh. To our lecturer, who is Professor Madya Dr. Muhammad Zahid bin Hassan. Okay, today I'm going to present our presentation, which is vehicle brake system. Okay, first of all, our objective is to demonstrate the concept, operation, and maintenance of existing and latest automotive brake system. Okay, next. Okay, this is our team member, which is first is me, Muhammad RIDZUAN bin Muhammad ZAID. Then AHMAD Daniel ZAINURIN. After that, Muhammad Iman HAQIEMI bin Muhammad ZAKI. After that, TUAN FAKHRUL Amin bin TUAN RAZILAH. And lastly is AHMAD AL-KARL bin Muhammad KHAIRUL ANUAR. Okay, next. Okay, theory of this brake system. This brake system operates on the principle of friction to slow down and stop a vehicle. When you apply the brake pedal, hydraulic pressure is used to squeeze the brake pads against the rotor, creating the necessary friction to convert kinetic energy into heat. Proper maintenance is crucial to ensure the safety and performance of the system. Okay, I'm going to pass to our next presenter.
Assalamualaikum warahmatullahi wabarakatuh. My name is AHMAD AL-KARL and my matrix number is B0921100023, and this is how we design our rotor brake disc. First, we will draw the rough design for the half cut for the rotor brake disc. The drawing is only the outline. Next, we will start constraining the outline with the dimension given. After we complete with the constraining, we will start extrude the design or pack the design so it will be in the 3D form. Next, we will make some holes, 5 holes for the nut to be fitted in, and we use the rotary function in CATIA V5 so the angle will be even. After that, we will draw spaces for the brake pad to be fitted in. After we complete, and this is our design for the rotor brake disc. After we completed the design, we will start the analysis. As you can see, we put on the clamp subfunction in the center of the rotor. Then we apply the surface slider in the front and the back of the rotor. After that, we apply the distributed force on the brake pad space with 2860 Newton forces, and we have to make sure that the force are inward toward the brake pad space because the brake pad will be clamped into the rotor when it's in use. After that, we insert and compute the frequencies case on the rotor body to see the analysis of the forces on the rotor brake disc when it's in circular motion as in the real time. By computing the frequency case, we were able to analyze the data more accurately as the real rotor should be functioning. And this is the data of the analysis that we have made. And that's all from me. Thank you. I will give it to the next presenter.
And for this slide is the result that we got from the analysis for material properties and others. For yang modulus, we obtained a value of 2.11 times 10 the power of 11 Newton meter. And for Poisson ratio is 0.219. The density of the iron that we use for this design is 0.008, and the thermal expansion of it is 1.21 times 10 the power of -5. Lastly, for yield strength, we got 3.1 times 10 the power of 8. After running the structural analysis, we obtained the value of 0.000944816 for the safety factor, which determined that the usage of this design is safe to use.
Assalamualaikum warahmatullahi wabarakatuh. My name is IMAN HAQIEMI with number matrix D0921100414. I will continue for the discussion. Okay, for this discussion, a safety factor lower the chance of product failing and raises the consumer safety. Safety is an important factor when it comes to fall protection and the safety gear. A structure failure could result in destruction, even death for the company as well as the financial loss. Okay, for the maximum von Mises stress, we get 3.44 exponent plus 0.11 Newton per meter squared. And for the minimum von Mises stress, we get 6 exponent plus 0.07 Newton per meter squared. All this value we use to calculate the factor of safety using the formula has been provided. Okay, for the formula is safety factor equal to yield stress over maximum von Mises stress. The value of the factor of safety, which is 0.009244186, we get. However, this figure is under designed. By modifying the material thickness, radius, and kind, we can raise the factor of safety. The factor of safety is impacted by this rotor's design.
Okay, lastly, for conclusion for our presentation today, as a conclusion, we are able to use CAD software, CATIA V5 software to design a model of rotor disc brake. We also able to analyze the material chosen and its properties if it is suitable to be used to design rotor disc brake. As a result, we obtain the value of 0.000924418 for the safety factor, which determine that it is safe to use material in designing motor disc brake. Okay, that's all from our presentation today. Thank you.